Okay, algebra. We are back for chapter 9, section 5 for the second day. So a quick lesson on second day where we're going to extend what we learned about factoring, quadratic, trinomials yesterday. So solving a polynomial equation. So rather than just using expressions today, we're going to look at equations. We're adding the equal sign, right? We'll continue to use factoring. So if you're solving a polynomial equation, solving it, you're finding the solutions, right? The values that would make the statement true. We also know that the equation needs to be set equal to 0, right? And solutions are synonymous with roots and the zeros of the equation. So I could ask you to find the zeros of the equation. You would set the equation equal to 0 and find the solutions, right? Also called the roots. Okay, so here we have our first equation, x squared minus 3x equals 28. So in order to solve this, we first need to set that equation equal to 0. So how do we do that? Go ahead and try it. I'm sure you're saying subtract 28, right? Subtract 28 from each side. Good, so when you subtract 28 from each side, we have an equation that we can now solve. To solve this, we will use our factoring. So we're going to create two binomial factors, just as we did yesterday, but now we have an equation rather than just expression. So the first term in each of the binomials will be, good, x. C is negative 28, right? So the signs in our binomial will be a positive and a negative. So what factors of 28 can give a subtract, really, to be 3? And so we're thinking 28 and 1 don't subtract to be 3. 14 and 2. But 7 and 4, right? 7 and 4. Which factor will be negative if we end up with a negative 3 in the middle, right? And it must be the greater of the two factors. So we have negative 7 and positive 4. When we FOIL this back, we see x squared minus 7x plus 4x minus 28, right? So we have the correct factors. Negative 7x plus 4x is negative 3x. Okay, so now that we know we factored this correctly, we're going to say what would make these factors equal to 0. So x plus 4 could equal 0, or x minus 7 could equal 0. So in this case, subtract 4 from each side and x equals negative 4, or add 7 to each side and x could equal 7. Very good. Again, you can check these values in the original if you wanted to, and you would know that this is true. Let's try it. If we plug 7 in here, 7 squared is 49 minus 21. 49 minus 21 is 28. And if we plug in negative 4, we have 16 plus 12, right? Due to the negative, 16 plus 12 is 28. So you always have the opportunity to check your answers. So go ahead and try that again with these two and come back and check your work. Okay, hopefully you set this equation equal to 0 first, right? And how did you do that? Subtract 24 from both sides. S squared minus 2s minus 24 equals 0. So here is our trinomial, and we now need to factor it. S times s is s squared. So what factors of 24 subtract to be negative 2? We have a negative c value, so we know we have plus and minus, right? And 6 times 4 is 24, and 6 minus 4 is 2. So because the b value is negative, the larger factor, 6, will have to be negative. So minus 6 and plus 4. When you FOIL that back, s squared minus 6s plus 4s is negative 2s minus 24. Okay, so the solutions to this trinomial, this equation right now, are what would allow the binomials to each equal 0. So in the first binomial, s would equal -4. In the second binomial, s would equal 6. If s is 6, then that binomial equals 0. Okay, so -4 and 6. In the second one, we have b squared plus 5 equals 8b minus 10. We have to move two things this time, right? So when we subtract 8b from both sides, we get b squared minus 8b plus 5 equals -10. And now we have to add 10 to both sides. And we have set the equation equal to 0, which is good. So we have b squared minus 8b plus 15. Okay, we're ready to factor. And the first terms will be b. Notice that our c term, 15, is positive, but the b is negative. What does that mean for our operations? They're both negative, right? Negative times negative gives you a positive c, 15. And what factors of 15 add up to 8? And that would be 5 times 3, right? So now the solutions would be the value that would make each of these binomials 0, right? So 5 minus 5 is 0, and 3 minus 3 is 0. Excellent. Okay. A multi-step problem. You'll probably need to pause the video and take this down, make sure you draw the picture. So we're looking at designing a flag with a team name in this area here. The entire flag requires 117 inches squared of fabric. So we're asked to find the value of W, okay? So the entire flag has this area. So do you remember how to find the area of this shape? Rectangle? So we start there. Area of a rectangle equals base times height, right? Base times height. And so, do we know the area? In this case, we do. We would say 117, right? Equals, how can we write the value of the base? Well, the base, if I want to use the bottom for base, either side could be used, but we could say it is 2 plus W plus 2, right? So what is 2 plus W plus 2? W plus 4, right? And then we have the height of W. Okay, so now here we have an equation that we are going to need to solve. And before we solve, we have to set the equation equal to 0. So what we might want to do is simplify the right side by distributing. So 117 equals W squared plus 4W. Now we can subtract 117 from both sides, right? And 0 equals W squared plus 4W minus 117. Okay, I need to make a little room here. So we have a rather large number in the C position. We have 117. We're now ready to find the solutions. We factor. 0 equals W. Now, 117 is negative, so this means that we will have to multiply a positive times a negative to get the C term. 117 is interesting. It's not a number we normally work with, right? So let's use our divisibility rules. Is this divisible by 2? No. Is it divisible by 3? Well, we just add the digits. 1 plus 1 plus 7 equals 9. So is it divisible by 3? Yes. And it's also divisible by 9, isn't it? So we could do a quick check. We could do 9 into 117. 9 goes once here. 27, 13. Ooh, look at that. 9 times 13 is 117. And 13 minus 9 is 4, which is our middle term. Yay. Okay. So we want the middle term to be positive. So which factor will be positive? The larger one or the smaller one? The larger, right? So we have 13 here, and we have 9 here. Okay, So now to find the solutions, we would say, what would make the first term equal to 0? And we see it is negative 13. And the second binomial would be 9. Now, let's see what the solution would be to this question, right? Well, the width is plane W. So would it be reasonable to say that the width is negative 13 inches? Not in this world, not in this dimension, right? So we're going to go with the one answer that is reasonable, which is 9. 9 inches is your answer. So sometimes with these quadratic equations, we end up with two solutions. One of them is not reasonable in the real world. So go with a reasonable one, since we live in this three-dimensional world. Okay? So have fun and good luck and have a good day. Here's your assignment for today. See you later.